In this lesson, we look at how to change the subject of the formula. And the first thing we need to be clear of is, what do we mean by the subject of the formula? It's the letter on the left-hand side of the equation, completely on its own, followed by the equal sign. So here's an example: A equals bx plus c. So A is the subject of the formula, and it's expressed in terms of the other variables and numbers. Now, it could be that we could be asked to make b the subject of the formula, and that means simply to find the value of b. So we would have to rearrange the formula so it looked like b equals to something. So you'd have a and x and c on this side, or it could be that you're asked to find the value of x. So we would have to rearrange the formula in order to make b, or in this case x, the subject of the formula. There are a number of quite clear steps in changing the subject of the formula. The first step is to move the other pronumerals and numbers, except the pronumeral you want as the subject, onto the right-hand side of the equation. Now, to do this, we have to move the terms, and so here are the steps to do that. We look to perform what we call the opposite operation, and what this means is that we add or subtract the same term or number to both sides of the equation, just like we would do when we're solving an equation. Or, if we're not going to add or subtract, we may need to multiply or divide both sides of the equation by the same number. Now, these steps are common when it comes to solving equations. So what we're going to do is to look at how these apply to certain key examples. In this example, we're going to have a look at the 4 basic operations that apply to most of the changes of the subject of the formula. So in this case, we're going to make x the subject of the formula, and in order to do that, we write down the formula first of all, and then you'll notice that we've got to get rid of the plus 3 in order to have x on its own. So we're going to subtract 3 from both sides, because subtracting is the opposite of adding. When we do this, we have our completed expression or equation, y minus 3 on the right hand side, and on the left hand side we have our subject, which is x. In this one, we've got 3x equals p, and there's an operation in here which is a times. So what we're going to do is we're going to divide both sides by 3, and that means that this will cancel out, and we're going to be left with x equals p over 3. Once again, x is the subject of the formula, and we've got all the other values on the other side. This is very similar to b, only this time we've got a division, and so we need to use our opposite operation to division, which is times. So we're going to multiply both sides by 2, and this will cancel out and leave me with x equals f times 2, which we write as 2f. And our final expression or equation in this case is x minus 5 equals r, and so what we need to do here is to add 5 to both sides. And by doing this, we cancel out the minus 5, and we have x equal to r plus 5. And in each case, we've used opposite operations to actually change the subject of the formula. And we're going to apply those, sometimes 2 or 3 of them, to an equation in order to get the subject changed correctly. In this example, we're going to make n the subject of the formula. So we write down the equation first of all, we identify that n has got to be the subject of the formula. So what we do is we take the n and we place it on the left-hand side, and we start to remove the other numbers or letters to the other side, so n is on its own. So the first thing we're going to do is to subtract 75 from both sides, and that will give us 40n. And you can see, so we're slowly getting rid of the unnecessary numbers or letters on the left hand side and moving them across to the other side. Our final step is to divide, because this is a times. We're going to divide by 40, and we're going to have to divide the whole side by 40, and we end up with the correct equation with n as the subject. N equals to c minus 75 all over 40. And now we're ready to put in the value of c to find n. Here we're going to make a the subject of the formula. Now this is a fairly common formula we know as Pythagoras' theorem. So we're going to have c squared equals a squared plus b squared, and we're going to make a the subject of the formula. So we'll write a squared plus b squared equals c squared, and this places a in the right position even though there are other variables that we've got to remove. So this is a plus b squared, so we're going to subtract b squared from both sides, and that leaves us with a squared, so we're getting very close now, equals c squared minus b squared. The interesting thing here is we've got to get rid of a square, and in order to do that, the opposite operation of squaring is finding the square root. So if we take the square root of the other side, we've actually removed the square from this side. So c squared minus b squared, if we take the square root of that whole side, we have our final equation where a is now the subject of the formula. This formula is a very common formula in maths, and it's used to work out the compound interest of an investment. So we're going to find the rate of interest of this particular formula by making it the subject of the formula. So we'll first of all write out the equation. So a is equal to p1 plus r to the power of n. We'll now move the r into its correct position, even though it's still with all the other variables. Now we're going to remove p, and to do that we've got a times there, or a multiplication. So we're going to divide both sides by p. That will cancel that out. We're left with 1 plus r to the power of n equals a over p. Now just as we took the power of 2 and made it into a square root on the other side to get rid of this power, we have to do the same here. We've got to find the nth root of this side. So what happens here is we've got 1 plus r, and the opposite operation of a power to n is the nth root of the other side. So we'll be able to look this up in the calculator. For example, that could be a value of 2, so that would be a square root, or it could be a value of 3, so that would be a cube root, and your calculator will help you work that out. So we're almost there. We've only got to get rid of the 1, so we're going to subtract 1 from both sides, and we end up with our final expression or equation. R equals the nth root of a over p, and we subtract 1 from all of that. And so there's our final formula, with r now the subject of the formula. This is a fairly common equation used to find future value of an investment, but we're going to find the value of m in this case by rearranging it. So on this side I'm going to write m times, and I'm just going to take the brackets away, and you'll see why in a moment. all over r, and that's equal to the future value. Now we're going to get rid of the r first of all onto the other side, so I'm going to times r on both sides. So we have m times 1 plus r to the power of n minus 1 equals the future value times r. Now in this next step, we've got to remember that this whole part here was actually the top of the fraction, the numerator. So in fact, it's still considered as one term. So if I divide this on both sides, I can do the whole next step in one hit. So we've got 1 plus r, and that's minus 1. So it's 1 plus r to the power of n minus 1. We're going to divide both sides with this same term. As I said, it was in brackets, so it's seen as one thing. And we end up with our final format where m is equal to the future value times r all over, and it's this part of the bracket. So I'm going to put it in brackets, 1 plus r to the power of n minus 1. That's our final format with m now as the subject of the formula.